All right, today we're going to talk about absolute value inequalities. Now, we know that an inequality is a greater than or less than statement, and of course absolute value is distance from zero. So what happens when we put both these ideas together? Yeah, we get a distance from zero that might be greater than or less than a certain value. Now, you were to have checked out the digital warm-up where you're going to see this first list of numbers. Looks like we have some numbers that perhaps might be, well, what do you think? What do you think about this first set of numbers here? They seem to be numbers that are greater than 4. So it looks like x greater than or equal to 4. What about the numbers right here, though? Are they greater than -4? No, they're less than -4. So we seem to have numbers that are greater than 4 and less than -4. Well, if you think about those kinds of numbers, you should agree that every number in that list has a distance from zero that is, are you thinking, greater than? That's correct. Every number in that list had a distance from zero that was greater than or equal to 4. So how can we write a statement using absolute value to represent being a distance that's greater than or equal to 4? Do you think it's the first one or the second one? Well, it has to be the first one, right? But as you can see, when you use absolute value, that can be interpreted as either being greater than 4 or less than -4. Again, when I use an absolute value statement that is greater than 4, well, that can be interpreted as a regular greater than 4 or regular less than -4. Let's try it again with this set of numbers. You were to have looked at this in the digital warm-up. Okay, the only numbers that we have are what's listed here. What do you think? These numbers, they seem to be less than 4. Less than 4. But they also seem to be greater than -4. Greater than -4. Now, there's something true about all the numbers in this list that are less than 4, but also greater than -4. That's right, they have a certain distance from zero. They have a distance that's less than 4. Every number in that list had a distance that was less than 4. So how can we write that as absolute value? Well, of course, it would have to be the absolute value is less than or equal to 4. But what I really want you to realize is that can be interpreted, hold on a second here, I got a little typo. This was supposed to be a greater than sign right here. I'll have to fix that on the digital warm-up, which means I want to choose the one that has the less than sign. I want to choose the one with the distance that's less than. And that means I can have a number less than 4 or greater than -4. And so again, when I have a less than sign, that can be split up as being less than 4 or greater than -4. Now, what's happening today is we're actually going to interpret absolute value inequalities. And our first order of business is to realize that when you have a greater than sign, like the first list of numbers, when you have a greater than sign, that's going to split up to be either greater than your positive value or less than your negative value. Again, when you have a greater than statement, that's going to be split up to be greater than the positive or less than the negative. And if you think about it, that's because the distance from zero is greater, which is why my numbers need to go away from each other. They have to go away either in the positive place or in the negative place. Now, as you can see, great or, we're kind of changing the way it's spelled with an or, is going to give us this kind of statement. So how can we use this to actually solve an absolute value inequality? Well, the main thing you have to realize in today's lesson is that all of these problems are going to be split. They're going to be rewritten. They're going to be interpreted as two statements. Because it says the absolute value is great or, I'm going to be great or than the positive. So I basically just rewrote the same thing. Or I'm going to be less than, notice I wrote as a less than sign, the negative or the opposite. And now what I have are two problems for the price of one. Yeah, I just need to solve both these inequalities, do good stuff like add 4 to both sides. Now it looks like I'm actually greater than 12. Over here when I add 4, I get a completely different number. For one thing, it's less than negative 4. Now when you look at these two statements on a number line, we have to make sure that we are going in the direction that we want to. And to be greater than 12 means that I'll be going to the right, so that looks good. And to be less than negative 4 means that I'll be going to the left. And so this looks good. This is what's supposed to happen when you have an absolute value that's greater than. By the way, we can also write this answer using interval notation, or we can say that we can go 12 to infinity, or perhaps negative infinity to negative 4. What about this absolute value statement? Looks a little fancier, but really it's just because it's not isolated. You see, you always want to, in algebra, isolate the heart of the equation. And the heart of the equation is this absolute value of 2x plus 17. So basically, anything that's outside of these absolute value bars needs to be dealt with first. What I mean is that we need to divide by 3. Now, once I divide by 3, my absolute value of 2x plus 17 is now greater than 5, but it's also isolated. Isolated means that I can now interpret it. I can split it. And remember, when you have a great or sign, you always want to split this into two statements. One of the statements is going to be greater than the positive. Basically, it's the same thing. But the other statement, I should say, or the other statement, is going to be less than the negative, or less than the opposite. And once again, I created two inequalities that I just need to solve. Do good math, like do opposite kind of stuff, subtract 17. That's just going to give me negative 12, but then when I divide by 2, I'll be greater than negative 6. Greater than negative 6. Okay, let's see what happens over here. You subtract 17. It gives you negative 22. And when you divide by 2, we're going to get negative 11, but we're actually going to be less than negative 11. Now remember, if we did this right, we should have an or type of shaded region. As you can see here, I'm marking my two endpoints. Certainly negative 6 is over here to the right because it's bigger. And it says greater. So if I want to be greater than negative 6, I would definitely shade to the right. This one says less than. Since I'm less than, I'm going to shade to the left. And this is perfect because this is an or statement, which, to go back to the beginning, is what I started with. I started with a great or sign. If I'm greater, that means my distance has to go away. You can also write this in interval notation, except since I can equal negative 6, I better use a bracket. Since I can equal negative 11, I better use a bracket. So, absolute value less than. Absolute value less than. This would be our other type of statement. Okay, make sure that you process that we're now talking about a less than sign. Of course, it is absolute value. So, what do? Well, I interpret it. I interpret as an and statement. Not to be an and statement means I'll be less than the positive, but greater than the negative. Now, if you look carefully, that is the opposite of what happened with the previous problem. But this is how you make sure that you get an AND statement. You want to be less than the positive, but greater than the negative. Okay, and again, this is all brought to you by this absolute value less than sign. What we see here is the absolute value of 4x plus 16 is less than 20. But more importantly, right now we see this absolute value is not isolated. You always want to isolate the heart of the equation. The heart of the equation is the part that's got like the function. Again, in this case, it's the absolute value. So before we do any funny business here, we have to subtract 16 and isolate the absolute value of 4x. Now, it says the absolute value is less than, the absolute value is less than 4. So what I'm going to do is I'm going to make the absolute value less than the positive. Well, that's interesting. Again, it kind of looks like I just wrote down the same thing. And I'm going to make this 4x greater than the negative. What you can see there is that I did two things. I flipped the sign and I used a negative. Well, actually, the same thing that you would have done in the other problem. It's just that now the signs are facing the right way, because when I start doing my algebra, I find out I'm going to be less than 1. But if I divide by 4 over here, I'll be greater than negative 1. Now, does this actually end up as an AND statement? Okay, well, let's find out. If you mark your endpoints, we want to be less than 1. To be less than 1 is to go to the left. And we want to be greater than negative 1. To be greater means I go to the right. So this is good. This is an AND statement. The numbers, the shaded region, is coming together. And if I write this with interval notation, I can just use some brackets, negative 1 to 1. Absolute value less than. I'm going to split the problem into two statements. One of them is less than the positive. It's basically the same thing. The other one's greater than the negative. I kind of flipped the sign and I made the number negative. You want to try a problem? This is actually intended for you guys to try. So you should push pause on the video and see if you can interpret this less than sign. By the way, the absolute value is already isolated, so I don't need to do any initial steps. You actually want to jump right in, and you want to split this thing up into two statements. A little bit of awkward silence. You should have split this into 3x minus 9 is less than the positive. So basically I rewrote the same thing. Hoping now if I do this right, I'll have 3x minus 9 greater than the negative. Okay, so that's following the steps. Of course, now you want to do the algebra. Looks like we're going to end up with 3x being less than 33, which means x is less than 11. What do we get over here? We're going to get 15, right? 3x is actually greater than negative 15. So if you divide that, we have we have x being greater than negative 5. It's supposed to be an AND statement. You always want to make a number line for your solution. Negative 5 is the smaller number. I'll mark it over here. 11 is the bigger number. I'll mark it over here. I'm less than 11, so that goes to the left. I'm greater than negative 5. And bingo, I'm in the middle of these two numbers. That's how it's supposed to work when it's an AND statement, or more specifically when the absolute value is less than. And then using interval notation, I can just say that I'm between negative 5 and 11, but use parentheses for your endpoints. So, we have two situations. We have a great or then. No, this is kind of on top of the writing, isn't it? We have a greater than. When you have a greater than, you're going to split it to be greater than. When you have a greater than, you're going to split it to be greater than the positive, which is basically the same thing. And then you're going to flip the sign to be less than the negative. And then over here, when I have a less than sign, I'm going to split it so that it's less than the positive. That's kind of the same thing. Greater than the negative. Again, I switch the sign and make it negative. And this is all brought to you by distance from zero, absolute value, and again, inequalities. Now, for homework, you guys get a chance to mess around with this little matching activity. And sometimes this can be a little confusing at first just because of the way it's set up. But why don't you go ahead and, well, you can either pull it up on your computer. If you're in class, of course, I handed it out. But I actually want to go over number 10. And I just want you to see that what's going to happen here is we're going to solve number 10, just like it's a problem, although it's a little bit of a tricky problem. And then we're just going to match it. We're going to match it to its appropriate interval here in column B. And then we're going to match it to the appropriate graph here in column C. So it just becomes like a little matching activity. All right. What do we have? We have something that needs isolated. Now, because of the order of operations, I want to always work from the outside to the inside. So I actually want to divide by -2 first, because that's on the outside. Now, when you divide by -2, you, not to be redundant, but you divide it by a negative. Remember, when you divide by a negative, now I need to take my time recopying this. When you divide by negative, you have to flip the sign. So that less than sign actually becomes a greater than sign. Okay? Listen, these parentheses, they actually don't really need to be here anymore because I took care of what was on the outside of the parentheses. But I still need to take care of what's on the outside of the absolute value. Because remember, you have to isolate. So I isolate by adding 2, and now I'm ready for business. Now I'm ready to do a great or statement. Now remember, a great or statement is going to get split into 2, right? One of them, where you take the absolute value, the 2x plus 4 part, and you make it greater than the positive. Basically, you make it greater than the same number. This is a great or, so it's going to be an or statement. I'm going to take my 2x plus 4, my absolute value, and then I'm going to make it less than the negative, less than the opposite. So I switch the sign, and we get a negative. All right. Well, subtract 4, divide by 2, lose my voice a little bit here, and you get greater than 2. Subtract 4, it's going to give you -12, right? Divide by 2, it's going to give you -6. Now, don't flip the sign. Okay, we didn't divide by a negative. You only flip the sign if you divide by a negative. But hopefully, we find out that we're good here. Now, actually, you could make the graph, or we could turn around and we could just look for a graph that matches. I'm going to make the graph. Sometimes it's easier to just kind of do the problem. Greater than 2, less than -6. All right, so we're going to go up here and look for a graph that's greater than 2, less than -6. Let's see, greater than 2, less than -6. I think I see it. It's number 4. It's graph number 4. So that means that what I'm going to do is pop a little 4 in here, because that's the graph that matches with column C. I guess I just need an interval that does the same thing, right? Greater than 2, less than -4. I think I see it. Greater than 2, less than -6, I meant. And that looks like that's this one, which is actually number 7. I'm going to pop a little 7 in here for column B. So that's pretty much how this works. You're just going to record the correct numbers. It's not going to make any kind of special code that's going to crack the crown jewels or anything, but you're just trying to get the right numbers to match accordingly with your answers. All right. Well, keep up the good work and do your homework.